we have been discussing about decision making, and we defined what decision making is. We were also able to solve some questions on the single stage. Is that so, Anne? We solved a question on single stage?
Yes.
Okay. So if we did that, so today I want us to begin by looking at another question. I want us to solve this question of May 2017. May 2017. May 2017. Question number 1A. Question number 1A. If you are there, let me know that you are there. May 2017. Question 1A. Have you seen the question in the past papers? Okay, so if you have seen the question, then the question reads like this. Frahia Limited, an events management company, is considering whether to advertise an outdoor concert. The sale of tickets is dependent on the weather as indicated below. If the weather is poor, it is expected that 5,000 tickets will be sold without advertising. There is a 70% chance that the weather will be poor. If the weather is good, it is expected that 10,000 tickets will be sold without advertising. There is a 30% chance that the weather will be good. If the concert is advertised and the weather is poor, there is a 60% chance that advertising will stimulate further demand and ticket sales will increase to 7,000. If the concert is advertised and the weather is good, there is a 25% chance that advertising will stimulate further demand and ticket sales will increase to 13,000. The profit expected before deducting the cost of advertising at different levels of ticket sales are as follows. We have the number of tickets sold and the profit. Now, the cost of advertising the concert is expected to be 15 million. You are required to use a decision tree to advise the management of Frahia Limited on whether the outdoor concert should be advertised. Now, in this case, what you can see is that this advertising company or this events management company is trying to make a decision. They're trying to make a decision. And we say the first step is always to identify the objective So what do you think is the objective of this company? If you are the owner of this company, what objective would you be pursuing? What do you think would be the objective of this company? Good, to maximize profits. It's to maximize profits. That's the objective. Then number 2, we said you identify the options. And we said options, it is what the company can do and they can choose and they can control. So what are the things that the company can do? From this question, what do you think are the things that the company can do?
They can advertise.
Yeah, they can choose to advertise. That is within their control. Good. What else is within their control? Actually, there is nothing else. Then, after you identify the options, the next step, number 3, is to identify the outcomes. The outcomes. And we said outcomes are beyond control and they have probabilities. So what do you think are the outcomes in this case?
The weather.
Good. Weather is one of them. Anything else? Anything else that you think is beyond their control? There is the issue of demand. There is the issue of demand. So the first thing that you do is to come up with a sketch. We are saying here, we can choose to advertise or not to advertise. You choose to advertise or not to advertise. Now, if you choose whichever, there are 2 possibilities of weather. There are 2 possibilities of weather. Weather can be good or can be poor. And when you advertise, again, there are 2 possibilities. You can stimulate demand or not stimulate demand. You can stimulate demand or not stimulate demand. But this one of no advert, the one of no advert will only have, will not have the issue of stimulating, because you're not advertising. You're not advertising. So stimulating or not stimulating appears where we advertise. Now with that, you are able to know that you require a decision tree that has 6 tails. It is counted like this: 1, 2, 3, 4, 5, 6. So we are going to do a decision tree that has 6 tails. We are going to do a decision tree that has 6 tails. A decision tree that has 6 tails. So this is how we go about it. This is how we go about it. You go to the page, to your book. You go to your book. And you estimate up to where the tree will get to. So we can bring it up to here. Up to here. Then here you write payoff. So that will be the end of it. Then this space that is left in between here, this is where now we are going to have the decision tree. This is where we will have the decision tree. This is where we shall have the decision tree. So you pick 6 tails here. 1, 2, 3, 4, 5, and 6. So the first one is drawn like this. So this one we will call it number 1. Those two. Then we have these ones. We call it number 2. Call it number 2. Then here we have another one here. Then this one will be drawn like this. Then here, remember I gave you the conventions, these symbols. I told you why they are drawn like this. So make sure you draw exactly the way I'm drawing. Make sure you draw exactly the way I'm drawing. So, as we said, this one is advert or advertise, and here no advert. No advert. When we do whatever we do, the weather is poor or good. Poor, good. Poor, good. And then we are told that there is a possibility you can stimulate demand. So you stimulate. Now the opposite of stimulate is just stagnant. You just remain stagnant, or you just retain. There is no increase. So here you can as well stimulate, or you can remain stagnant. Yeah, so that is how the tree is drawn. Once you're done after that point, write OK so that I proceed from there. Once you get up that point, say okay. Yes, I can see those who are saying okay. The others. Yeah, good. It appears that we are all there. So if we now start reading the question again, we'll be able to feel the information. From bullet 1, we are told if the weather is poor here, if the weather is poor, it is expected 5,000 tickets will be sold. So you come here, 5,000 tickets, you can write them down here, 5,000 tickets. Without advertising. So this is without advertising. There is 70% chance that the weather will be poor. So the probability of the weather being poor is 0.7. You can put it even here. 0.7. Higher. We go to bullet 2. If the weather is good, it is expected that 10,000 tickets will be sold without advertising. So for the weather to be good, we'll sell 10, or if the weather is good, we'll sell 10 tickets. And obviously the chance of the weather being good should be 0.3 because the two probabilities must add to 1. This plus this must be equal to 1. Higher. The next is saying if the concert is advertised and the weather is poor, the concert is advertised and the weather is poor, there is 60% chance that advertising will stimulate further demand and ticket sales will increase to 7,000. So that means here we have a 60% chance we increase, and that means we are moving from the current. You see here, when we were poor and there was no advert, we had 5,000. So when we stimulate, it goes to 7,000. So you take 7,000 tickets. 7,000 tickets. That tells you the probability. Okay, let me go to the next point. If the concert is advertised and the weather is good, there is 25% that advertising will stimulate further demand and ticket sales will increase to 13,000. So that means if we are good here, we have 25% chance, 0.25. And we will go to 13,000 tickets. We will go to 13,000 tickets. And then, that is all that we are told. But you can see we have some information that we have not filled. The first one is here. When we are stagnant, it means we have done the advert, but nothing has changed. Nothing has changed. So if nothing has changed, we just then sell these 5,000. And the probability, because I said this should be 1, will be 0.4. And then we sell 5,000 tickets. We sell 5,000 tickets. Then from there, we come here. This should be 0.75. We sell 10,000 tickets. 10,000 tickets. Because it's this one. And then we have the probabilities here. When we are poor, this is 0.7. When we are good, this is 0.3. That's 0.3. Now, the next thing that we need to identify are the payoffs. If you look at the table that follows, it says that the profit expected before deducting the cost of advertising at different levels of ticket sales are as follows. The number of tickets sold and the profit. Sasa unafuata hii. Where 7,000 is, you can see if the payoff is in millions, 7,000 has 35. So tuweke 35 here. Then 5,000 has negative 20. 13,000 has 150. 10,000 has 90. 5,000 has negative 20. And 10,000 has 90. Yeah. So that is how a decision tree is drawn. So once you draw a decision tree that way, the next thing now is called computation of expected monetary values. So down there we say computation of expected monetary value at node, the node, we start with node 1, this one here. Now, when you are computing these expected monetary values, what you need to look for is what kind of lines are going out of that node. This kasako ndio inaitwa that node. So the type of lines going out, they are complete. So if the lines are complete, these ones are called incomplete, these are called complete. So if the lines are complete, you just multiply these probabilities by the payoffs here as you add. So for node 1, and there is, for node 1, it is going to be 0.6 times 35 plus 0.4 times minus 20. So give me the answer. Yeah, so I can see 13. Then we go to number 2. Number 2, it is the same argument. You take this 0.25 times the payoff, which is 150, plus 0.75 times the payoff, which is 90. Yeah, I can see the figure. Let's said and the other said. Yeah, I can see 105. Now, we go to number 3. Number 3, the same, because you can see the lines going out are complete, so it will be this 0.7 times the payoff of where it is going. It's going to number 1. And number 1, we had 13, this one. Plus 0.3 times where it's going, number 2 here. And number 2 is 105. Then you check which line is coming in. The line that is coming in is this one that is incomplete. And this advertising has a cost. We have a cost of 15 million. So that cost is normally put here on the graph, and you put it in brackets that way. That way, 15. You put it in brackets. So you subtract it here. So work that out. Waiting for the answer. Yeah, 25.6. 5.6. So we go to number 4. Number 4, we do the same. The lines are complete, so it is 0.7 times what we have there, minus 20, plus 0.3 times 90. Now this one, there is no cost. There is no cost. Where this one is coming, this incomplete line, there is no cost. So we are getting 13. We are getting 13. Then from there, we go now to node 5. Now because you can see node 5, the lines going out are incomplete. What we do there, we select the higher of where these two lines are going, here and here. So the higher in 3 and 4 is this one. So this one, it is the higher. EMV at nodes 3 and 4, which is equal to 25.6. And when you pick that, you come and mark this way. We have picked it from node 3. You mark that way. You mark that way. So once you have done that, the advice that now you shall offer to your client here, the advice that you shall give to your client is that they should advertise the event. So advertise the event. They should advertise the event. And for some reasons, if anyone asked you what is the value of information, what is the value of information, you simply get the difference between these two. You see these two that you are comparing here, where we are saying the higher. Those two, the difference is the value of information, 25.6 minus 13. So give me that answer. 25.6 minus 13. One person has given, the others 12.6. Good. 12.6. Yeah, so that is how you deal with a multiple stage. This is a multiple stage decision question. Any question? If you are okay, say yes so that I move to the next, or we move to the next agenda. If you are okay, say okay or say yes. Yeah, I can see we are okay. Now for your assignment, which I would like you to do, and you submit your work, you will try this question of that was examined in November 2017. November 2017, go to November 2017, or just write November 2017, question 4A. November 2017, question 4A, and then you try April 2025. April 2025, question 1B. So that brings us to the end of that chapter 1 and to the beginning of our next chapter, chapter number 2. So we are now in chapter 2, which is called cost forecasting. Cost forecasting. Cost forecasting. And we write this. This is the process of predicting the amount of costs. This is the process of predicting the amount of costs. Full stop. In cost forecasting, classification of costs is very important. Classification of costs is very important. First of all, the most relevant classification methods are number one is behavior or activity level. Behavior or activity level. And under this, the first category we have is called fixed costs. Fixed costs, and we write that this is a cost whose total amount, this is a cost whose total amount remains unchanged. Total amount remains unchanged irrespective of changes in the activity level. Irrespective of changes in the activity level. Full stop. It is usually expressed as a single figure. It is usually expressed as a single figure. The second class that we have here is variable costs. Variable costs. Variable cost, and we write that this is a cost. This is a cost whose total amount changes. Whose total amount changes in a direct proportion. In a direct proportion as the activity level changes. Changes in a direct proportion as the activity level changes. Full stop. It is usually expressed on a per unit basis. It is usually expressed on a per unit basis. C. Mixed or semi-variable costs. Mixed or semi-variable costs. Mixed or semi-variable costs. And we write that this is a cost that has both This is a cost that has both fixed and variable components. That has both fixed and variable components. Okay, let's go to the second base that we have. It's called product. Product. And the product A is direct costs. Direct costs. Direct costs. And we write that these are costs which can, these are costs which are significant. These are costs which are significant and can clearly be identified. And can be clearly identified with the product. And can be clearly identified with the product. The sum is known as prime cost. The sum is known as prime cost. They are treated as variable costs. 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 Higher B, we have indirect costs. Indirect costs. Indirect costs. And we write that these are costs which are insignificant. These are costs which are insignificant and cannot be clearly identified with the product. They're usually insignificant and cannot be clearly identified with the product. Full stop. The sum is known as overheads. The sum is known as overhead. The sum is known as overhead. Full stop. They are usually treated as fixed costs. They're usually treated as fixed costs. They're usually treated as fixed costs. Yeah, so that is what we mean by cost forecasting. It is about trying to tell in advance how much cost we are likely to incur when we do what we want to do. And this is usually very, very important for budgeting purposes and other reasons. Now, when you want to classify, to forecast costs, it is always important you classify, you categorize the costs. And we have very, very many methods of classifying costs. And I believe you came across this when you are doing your management accounting. And for this topic, there are two bases that are very important. One is the behavior and the other one is the product. And these are the categories that we have, and you'll be coming across them as we go by and by. Now, on your own later, you shall check the question of April 2025. Take note of that question. April 2025, question 3A. April 2025, question 3A. Yeah. Then down there we write that cost forecasting is based on the assumption that cost forecasting is based on the assumption that colon, and you write this equation. Total costs is equal to fixed costs plus variable costs. Is based on the assumption that total cost is equal to fixed costs plus variable costs. The next point you write is that this is then expressed in form of a linear equation as this is then expressed in form of a linear equation as y is equals to a plus bx, where y will always represent total costs, a will always represent fixed costs, b will always represent variable costs per unit, x will represent number of units. So that is the assumption that we make when we are forecasting costs, that the total is a makeup of two, fixed and the variable. And then we also assume there is a linear relationship. Later on we'll be discussing about this. That makes us to have y is equals to a plus bx. This equation is very, very important. As long as you are in advanced management accounting, you really need to understand well the meaning of this equation. It will not only be used in regard to costs, but it will also be applied in regard to other variables, other random variables, where y will always represent the total, a is representing the fixed component, b is representing the variable component, and x is representing the activity level. Down there we write, we can give it steps to follow in cost forecasting. Can separate them when we write steps to follow or to take in forecasting. Steps to follow in forecasting. One is identify the dependent variable y. The dependent variable y. Identify the dependent variable y. First up, this is the variable. This is the variable being predicted. This is the variable being predicted. This is the variable being predicted. Number 2. Identify the independent variable x. Identify the independent variable x. The independent variable x. And write that this is the variable whose change. This is the variable whose change makes the values of y to change. Whose change makes the values of y to change. The values of y to change. Number 3, gather data for x and y. Gather data for x and y. Number 4, analyze and plot the data on a graph. Analyze and plot the data on a graph. Number 5, observe the pattern on the graph. Observe the pattern on the graph and develop an appropriate function. And develop an appropriate function. Number 6, test reliability of the function. Test reliability of the function. Test reliability of the function. So those are the steps that you need to take when you want to predict costs. Later on, you will check this question that was examined in May 2012, question 1A. May 2012, question 1A, it was about those steps. The next thing is cost forecasting methods. Cost forecasting methods. So we shall first of all list them, then we'll discuss each at a time. The first one is called scatter diagram. The second one is called industrial engineering method. The next is called accounts analysis. The next is called HIRO. The next is called simple regression. And there is another one called multiple regression. Although this is just but one method, you can also call them regression. Then when you are discussing now, you differentiate between multiple and simple. So those are the, or there is another one that we need to also look at. It's called learning curve. learning curve. Learning curve. So those are the methods that we need to look at. So let's start with the first one, scatter diagram method. Scatter diagram method. Scatter diagram method. And we write that this involves plotting the values on a graph. This involves plotting the values on a graph. Full stop. The pattern observed is used in predicting the costs. Yeah, that method is as simple as that. You just get the values. This is y-axis and this is x-axis. You plot them. If you find the points are moving like that, then you are able to tell that as the units are increasing, my costs are increasing. If you find that they are scattered all over, that tells you there is no relationship. So whatever you see on the graph gives you an idea of whether you shall, on how to forecast that cost. So let's go to the next one. Industrial engineering methods. Industrial engineering methods. Industrial engineering methods. Industrial engineering methods. And we write that this is where a professional engineer uses professional knowledge, skills and experience. Professional knowledge, skills and experience to express the relationship. Between inputs and outputs. In physical quantities. Full stop. The quantities are then expressed in terms of money. To get the total cost of the output. Yeah, so what happens here, you get to an engineer. For example, you want to come up with a house. So this is the output. Now this engineer will give you what they call the BQ, the bill of quantities. And this will be showing you the inputs. Like maybe they can tell you you require stones or bricks. you require sand, you require cement, and so on and so on. They will give you in terms of quantities. Like maybe stones, you are told you require 10 tons. Sand, maybe you require 20 tons. Cement, maybe you require 100 bags. So these quantities cannot just be given by anyone. They require someone who is trained, someone who is skilled and experienced in that field. When they give you this BQ, you now go to the market and find out what is the cost of 1 ton of stones. Maybe you find it's 5 shillings. So that means you'll spend 50. What is the cost of 1 ton of sand? Maybe it's 2 shillings. That means you spend 40. What is the cost of 1 bag of cement? Maybe it's 1 shilling. That gives you 100. So this tells you that for you to build your house, you require this 50 plus this 40 plus 100. That gives you 190 shillings. So if you have the money here and now, you just now begin the process. You call the engineers, the foodies, and you go to the site and you begin. That's what we call industrial engineering. That one also does not have any computation. So we move to the next method, number 3. Accounts analysis method. Accounts analysis method. Accounts analysis method. And we write that this involves classification of costs. This involves classification of costs into fixed and variable components. Into fixed and variable components. Full stop. The totals are then used. The totals are then used to develop an equation of the form. Y is equals to A plus BX. An equation of the form Y is equals to A plus BX. Yeah, so this one is as simple as that. I want us to go to, I'd like us to go to the question of December 2004. December 2004. Question number 1. If you see it, let me know. Just read through the question. Read through the question for a minute as I do something. Then I'll be back with solve. 1 or 2 minutes.
Nominated first paper can share for group. Thank you.
Okay, so I believe you have read the question, and if you have, here we have the cost item. Then we put the fixed and the variable here. So, this information we are going to get it from the first table, as you can see. The first one is indirect materials. Indirect materials. We are already told the cost is variable, so that 7,500. 7,500. Remember here shillings are in thousands. Sorry, I'm supposed to put here under the variable. The next one is indirect labor. Indirect labor. Indirect labor. Now, indirect labor, the total of it is 194, and we are told 171 is fixed. So I will put 171,000. So tell me what's the balance when you subtract 171. The balance? $23,200. Then the next one is rent, which is fixed. Rent is fixed, and we are told it is 236,420. Then we have electricity, which we are told is variable 27,210. Then we have depreciation. Depreciation, we are told it is fixed, 181,000. You put it here. Then we have maintenance. Maintenance is 8,500 fixed. 8,500 fixed. So the total is 24,330. So give me the balance. The balance, give me the balance. Let's have many people giving the figure. $15,830. Then we have taxes. Now taxes, we have 6350 being fixed. 6350 being fixed, and the total is 14,100. 14,100, that is the total. So give me the balance. $77.50. Then we go to data. I don't know whether your question paper is good in terms of the typesetting there. For data, the fixed is 94.70. The total for data is 11 to 20. So if your typesetting there did not come out well, that is the way it should be. The total for data is 11 to 20. So subtract this 94.70. Let me get figures from many people. Yeah, 1750. And the last one is technical support. Technical support. The fixed is 16,940. 16,940. So that is all. So with that, now you proceed and get the total. Give me the total for the fixed. Fixed 62,680. Someone else? Yeah, I can see different figures. So some more to come so that we agree. So 629, 680. So that is the one that is popular. Give me now the total for the variable. One that 10, 240. Let me get another one. Yeah, 113, 240. Now, when you do so, you now go down there and tell us that our A is 629, 680. That is the fixed amount. Then our B will be 113,240. You divide it by the total number of units. The total number of units is 800,000, and because our figures are in thousands, we divide by 800. We divide by 800. So when you divide by 800, $141.55. $141.55. So that means our equation is y is equals to 629, 680 plus 141.55x. That is the equation that you get when you solve using accounts analysis method. So that method does not have a lot of issues, and they rarely examine it. So you only need to know that when you come across it, you get the cost item, you separate them into fixed and variable, then you get the value of B, and that's all. That's all regarding that method. Let's go to the next method, high-low method. High-low method. That should be method number 4 now. High-low method. We write that this involves identification of the highest and the lowest values of x, and the lowest values of x, the highest and the lowest values of x, together with their values, of y, together with their values of y. First of all, using the two sets of points, an equation of the form y is equals to a plus bx. An equation of the form y is equals to a plus bx is then developed. Okay, so now we are going to use the same question. The same question that we had the December 2004. Question 1 now, B. And because we already have read the question, we are going to use the information in number 3. Information number 3. That's the one that we are going to use. Now that information or that table has 3 columns: overhead costs, production units, and price index. Now tell me which one of those is our X. Which one of those is our X? The overhead costs, production units, and price index. Which one do you think is our X?
Price index.
Someone says price index. Someone else? The others? Yeah, another person says production units. Yeah, production units is our X. Aya, which one is our y? Which one is our y? Y ni gani? Yeah, the overhead cost. So X is the production units, because units are the ones that are making the cost to change. If you remember the steps that we have written down, we have said that the independent variable is the one that makes Y to change. So the units are the ones that are causing a change. So in that case, I would like you to scan the column of units and tell me which is the highest number of units you can see. The highest number of units you can see. The highest number of units you can see. When you look at the units, highest number of units you can see. Yeah, good. So that 98,000, you pick it together with its cost. Its cost is 377,640. So you say form is y is equals to a plus bx. So the equation, you take the first one, tumesema ni 377,640 is equals to A plus 98,000 B. This is the highest. The highest. And then the lowest that you can see there is 56,900 with a cost of 717,670. 717,670. We have A plus 56,900. This is the lowest. And what you notice with this, the selection is only done for the units. We don't go selecting the cost. This could be the highest, though it need not be. This could be the lowest, though it need not be. As long as it is the cost of the highest units, you take it, whether it's the highest or not. As long as it is the cost of the lowest units, you take it, whether it is the lowest or not. Yeah, so we don't select here, we select here. Now with that, you proceed to solve this. So tell me 77640 less 717,670. $59,970. I have this one, 98,000 minus 56,900. Let everyone give the figure. Our time is almost over. Need to move fast. 41,100. So B will be 59,970. You divide by 41,100. 1.459, let's go for that. Or 1.46, either can do. Let me go for 1.6, I mean 1.46, so that we minimize the decimals. Higher. Now you just substitute. You say 777,640 is equals to A plus 98,000 times 1.46. So based on that, tell me the value of A. Give me the value. $634, $658. You may differ slightly. Depending on how many decimals you have used here. Yeah, like I can see there is 658 and 560. So they are okay. So that means our equation is 634, 658 plus 1.46x or 1.45859. Yeah. So for your assignment, I would like you to try this question of December 2007. December 2007, question 1C, and another one of June 2003. June 2003, question 4. So that now when we meet next time, we shall look at regression, simple regression. If you are okay, you can say yes so that we can close for today. You can say yes, I can see the yes. So thank you very much for attending. Let's meet in our next lesson. And continue helping us in marketing. When you come across anyone who is interested in our programs, let them know that we are on. Thank you very much. Good night.